All right, geometry, here we are, 7.3, similar triangles. Now this may look like a familiar lesson to you, and it is. We've done this before. We're just going to be using it for a slightly different purpose today. So kind of doing a refresher today. We're going to be identifying triangles using the AA similarity postulate and SSS and the SAS similarity theorem. So here we go. Let's get right into it. So the angle-angle similarity, you might remember this. So remember that from probably the last lesson, you may remember that if you have two angles congruent on two different triangles, then the third angle has to be congruent, because we know that in every single triangle, the total there of the angles has to add up to 180 degrees. So it doesn't really matter what they are. If we have two angles that are similar, or congruent, I should say, in similar triangles, then we know that the third one is also. And if we have all three angles that are the same, then we are dealing with similar triangles. All right, so that's called the angle-angle similarity. Next, we will look at an example of that. So here it says, determine whether the triangles are similar. If so, write a similarity statement. Okay, so we're going to be looking here to see what these are. We know this one's actually pretty straightforward and easy. We know here that the 90 is the same in both. But then the other angle that we know here is we have a 44 and we have a 47. Okay, so it might be a good idea just to check to see whether or not this could equal 47 and this one could equal 44 to make that a similar. But remember that in a triangle, they have to add up to 180 degrees, right? So let's see what this would be. If we have 90 here plus 47, we see that if we add those together here, we get 137. If I subtract 137 degrees from 180, then I see that I would have 43 degrees that are left. So this would have to be 43 degrees, okay? And since that's 43 degrees, nothing matches this 44 here. So at that point, you know, since there's no two angles that are the same, that these are not similar. So you would say no, because no two angles are the same. Okay, example 1b here, this one's interesting. We have parallel lines. So we know that parallel lines have the exact same slope. Okay, so we're looking at the similarity between the smaller triangle here and then the bigger one that kind of captures that. So we know that angle L is congruent to itself, right? So angle L is congruent to angle L in both of these triangles. And then, since this angle here, since this line LJ is being bisected by parallel lines, we actually know that P and J are the same. Okay, so we know that angle P is congruent to angle J. And the same case can be made for the Q and K here. So Q would be congruent to K. And again, this is because we have parallel lines cutting a transversal. So we know that they create, from things that we studied in the past, that these create congruent angles. Okay, so we know that angle Q is congruent to angle K. All right. If it says for 1b, one of the directions that they want you that they stated here was, if we determine that they are congruent, we need a similarity statement. Okay, so we know L is congruent to L, P is congruent to J, Q is congruent to K. So I'm just going to name one of the triangles. Okay, so I'll start with a small one. I'll say triangle LPQ. And again, order is important here. Is similar to triangle. So in the big one here, that would be L has to be corresponding to L. So L would match the L. P matches J, so I would say J. And then Q matches K, so K. In that order, okay? So that is your similarity statement. And again, you can start with whatever order you want and whatever triangle you want. You just got to make sure that they match, right? The L's match the L's, the P matches the J, the Q matches the K in the correct order. All right, next we have the triangle similarity SSS. All right, so if we have three side lengths that are congruent or similar or proportional, I should say, then we know that we are dealing with similar triangles. All right, so what you're going to want to do is identify whether or not the corresponding side lengths create proportional statement, a proportional statement. For instance, here they color code it to make it nice. So if you looked at the green lines, right? So green lines here, LJ, we just call it LJ. LJ, if LJ over QM, and notice they don't give us any values here, okay? They just say if that is equal to JK, which would be the red, over MP, the red on this one, and that is equal to LK over QP, if that is true, then we know that the triangles are similar, okay? That's the side similarity. So you're setting up these proportions to see whether or not that is a true thing. And whatever those come out to, we learned yesterday, is called the scale factor, right? So whatever these fractions are equivalent to, if you are given numbers, would be called the scale factor. Lastly, we have the SAS triangle similarity. So it says here if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides on another. And the included, now that's a key thing that you're going to want to highlight in your notes. The included angle. Okay, when it says included, it means the angle that is sandwiched between the two proportions that we've created. Okay, in other words, the angle that would not work here, so this would be a non-example, is if it said something like this, if it was looking at this angle and this angle, that would not be an SAS. That would be a side-side angle, and we know that there's no such thing as a side-side angle or an angle-side. Angle side similarity statement, because there's two possibilities there. Okay, so it has to be sandwiched in between the proportions that we're creating. That's very important for this one. All right, so I think I've talked enough about that one. Let's just do some of these here now. So if I, let's get off this eraser. Here we go. So example 2, it says determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So here we go. Let's see if we can use some of the things that we just learned. So here on 2A, looks like I don't know anything about the angles, right? So I'm looking for, if I don't know anything about angles, I'm going to see if the SSS thing works, okay? So what I'm going to do for 2A to solve this is I'm going to set up the proportions, and how I'm going to determine what's what is I'm just going to use the order of like the greatness. So in other words, the biggest side for this JLK triangle here is going to be this 16. And the largest side on the other triangle here would be the 12, right? Okay, so I'm going to set it up that way. I'm going to check, okay, so it is 16 over 12 equal to, and then I'm going to go to the medium, like the next greatest. Okay, so the next greatest here, maybe I'll change colors so you guys can follow with me, would be the 12 on this one and the 9 on this one. So I would say 12 over 9, okay? And then for my final one, we'll use green here. We have the smallest side length, so 8 over 6. Okay, so we're going to check these fractions out and see if they're equivalent. So if you do these out, you can just reduce the fractions as well. 4 goes into both of these, so we'd have, this reduces to 4/3. 3 goes into both of these, so this also reduces to 4/3. And then 2 goes into both of those, so we have 4/3 for each one of them. If that is true, then by side, the triangles are similar. So I'm going to make a similarity statement. I'm just going to call the first triangle JLK, and I have to make sure that I go in the same order here. So JLK, we kind of go from medium side length to small to large. So I have to do the same on the other one. I got to be very careful about my order. Okay, so I'm going to start with the medium side length, and we're going to go toward the small. So we're going to start with Q here, and you do the medium to the small to the large. So in that order, it would be Q, M, P. Okay, so that would be your statement, and side is the reason. Next for 2B, notice here you got to use some things that you've already learned. Okay, so on 2B, with these triangles, we have two lines that are intersecting here in the middle that create these triangles. When those two lines intersect, it creates what we call vertical angles, and we know that vertical angles are congruent. Okay, so those are congruent. And if you look at this and you notice this, we have an angle, a side, and an angle. Okay, angle, side, angle. Sorry, I said it backwards. Side, angle, side, where the angle is sandwiched in between. Right, so this is an example. This will be an example of SAS if we can make sure that they're proportional. All right. So you got to be a little bit careful here, okay? Because these triangles are actually, you could say that they're twisted on one hand. So, in other words, this 10 here actually corresponds with the 20 down below, and the 11 corresponds with this 22. And the reason that I know that is I'm just going with the biggest on each one. Okay, so I'm going to say 10 over 20. I got to make sure that that's proportional to 11 over 22. Okay, and I went with the smallest here on each triangle. So these are both the smallest, right? And these were the largest. So set up the proportions, like make sure that they're corresponding. So make sure you're looking at the smallest on each one and then the largest. And when you reduce these, they both reduce to 1/2. Okay, so that checks out. And we have the angle congruent in between. And we know that because of vertical angles. Therefore, by SAS, these are similar. And the statement would be this: triangle TWZ is similar to, now you got to be careful, we went TWZ, so we went small to large to unknown. So we got to do the same thing on the other triangle here. So we'll start with small to large to unknown. We'll go in that order. Okay, so let's do it here. If I put that down, we'd start with Y, so triangle YWX. Okay, that would be your similarity statement. And remember that order is important. T has to correspond with Y, W has to correspond with W, Z has to correspond with X. Okay, so here's some properties of similarity that you may want to jot down. I might give those to you in your notes. The reflexive property is just basically like if you have a triangle that's listed, it's similar to itself. The symmetric property says that we can switch the order, right? You guys should be pretty familiar with these terms. So like this one starts with ABC to DEF. Well, you can do it the other way, right? As long as you keep the order of the triangle the way that it's labeled intact, you should be fine doing that no matter what. That's a symmetric property. Then the transitive property, remember that if we have something like this where you have ABC similar to DEF, and we know DEF similar to something different, we can cut out this middle guy, okay? That's called the transitive property. So we may use that from time to time in here as well. Let's see if there's any examples of this. We'll see here. So it says find the measure, okay? So here's an interesting problem. So in this case, we know a couple of things that are not listed. We know that this angle is congruent. We also know that since these are parallel lines, that this angle is congruent to this angle, and this angle here is congruent to this angle. Again, it's because they're parallel lines cut by a transversal, so that's how we know that. So by angle, 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 we know that these things are similar, so we're good to go. Now what we have to do is solve. So what I like to do with these is I like to actually make my similarity statement first. So if I said, so I know they're similar, right? So I'm going to make my statement. So let's look at triangle. Let's just call it, look at the small one there. Let's just call it QMN. Okay, let's figure out what triangle that is similar to. All right, so if we go in the same order as the angles that are listed there, QMN, it went from like 2 dash marks to 1 to 3. So I'll do the same on the big one. So the 2 dash marks would be P, so we'll go PMO. Okay, so that's the similarity statement. I like to just have that so that I know. Now I can set the proportions up. Okay, so we know that that QM, this side length here, this value of 5, that value, just so you guys are aware, is just from Q to M. Doesn't include the Q to P part. So that 5, okay, so MQ part is 5 on the small triangle. We're going to put that over the big part of the triangle, which would be the PM part. So PM is going to be 5 plus X. Okay, so we have 5 over 5 plus X because the total distance from P to M would be 5 plus the unknown X. Okay, and then we're going to set that up. That has to equal the 6 over here, which is MN. Okay, MN corresponds with MO. MO would be the total of 6 plus 3 3/5. So if I add those two together, I would get 9 3/5. So I would set it up like this. Okay, and then we have to, when we have equivalent proportions like this, we are going to cross multiply to solve for our X here. Okay, so we got to figure this out. Once we know our X value, then we can find the total for these. Okay, so let's try that out here. So let's solve for x. So if we cross multiply here, we have 6 times 5 plus x equal to, if we did 9 3/5 times 5, quick calculation there I have on a calculator gives me 48. Okay, so when I simplify this here, I'd have 30 plus 6x by distributing equals 48. Move my 30 to the other side by subtracting. I get 6x is equal to 18, therefore x is equal to 3. Okay, so x is equal to 3, that is QP. So QP is what they're looking for, right? QP is equal to 3. And then if I plug that in for MP, excuse me, if I plug that in here, 5 plus 3 would give me MP. Okay, so 5 plus 3 gives me 8, so MP must equal 8. Okay, so that's how I got those two. And let's keep cruising on to 4B. So for 4B, kind of a similar thing here. We know that this angle here is congruent to this angle here. We have vertical angles, so this angle is congruent to this angle. And then by the third angles theorem, we know that this one here is congruent to this one here. So I'm going to make my statement. Okay, so triangle WSR is similar to triangle, I can't really see it here, so let me zoom out a little bit. So this would be T, okay, because T corresponds with W. And then we'll go to the 3 hash mark here, which would in this case be the V, so TV, and then the 2 hash mark would be R. R corresponds with R in this case. Okay, I can use this as kind of a cheat, right? So now I know what I'm doing. And then I also want to look at what I'm given, right? So I'm given WS. Okay, well, if I look over here, WS are the first 2 letters, so I want to relate that to TV. Okay, so WS over TV, if I put that in, my WS is 8, my TV is 10. Okay, that has to be equal to, and now let's look at the others. So we have WR that we kind of know something about. WR is here. That's going to be x plus 6. So I'm going to put WR, which is x plus 6. And then notice WR relates to the first and the last letter, so that would have to be related to TR. Okay, so I'm going to put that over TR. TR in this case is 2x plus 6. And then I'm going to cross multiply to solve. All right, so I'm going to cross multiply these. So if I do that here, 10 times x plus 6 has to equal 8 times 2x plus 6. And then we're going to just distribute. So we have 10x plus 60 equals 16x plus 48. And then we're going to combine like terms. So I'm going to subtract 10x from both sides. And then I'm going to kind of move my work over here. If I subtract 10x from both sides and then also subtract 48 from both sides, that'll combine my like terms. So I'm going to do it all at once. So if I do that, these go away, and then on my left side, I'm left with 12, and on my right side, I'm left with 6x when I do the math out there. Okay, therefore x is equal to 2. Now they're not asking for x, they're asking for WR and RT, so I got to plug that back in. So if I plug that back in for WR here, WR would equal 2 plus 6, which is 8. And for RT, if I plug the 2 back into this guy right here, TR would equal 2 times 2 is 4 plus 6 is 10. So my 2 answers would be 8 and 10. And I'm done with 4B. Lastly here, kind of a cool problem for example 5. It says Adam standing next to a building in Columbia, South Carolina. He's 6 feet tall and the length of his shadow is 9 feet. If the length of the building is 322.5 feet, how tall, the length of the building, oh, maybe this meant if the length of the shadow of the building is 322.5 feet, how tall is the building? Okay, so what we're going to do, because that's a typo, it should be shadow, the length of the shadow of the building, I think that's a typo, is 322.5 feet, how tall is the building? So what we're going to do is we're going to do the actual, here's a little hint, you want to make sure that you do the actual length over shadow, and set that to equal the actual length over the shadow. So set up the proportion correct. That's just a way of showing that it's the same piece on both numerator and denominator there. So if we do this for the guy, so one would be for Adam, right? Adam would be on one of these and the building would be on the other. So we'll set it up that way. Okay, so for Adam, his actual feet his actual height is 6 feet and his shadow height is 9, or his shadow distance. So it would be 6 over 9. For the building, we know that the shadow piece is 322.5, because I believe that's what how tall is the building? Yeah, I'm guessing that that's what they want. And they're looking for this actual piece. So we're just going to cross multiply here. Okay, so we're going to have 9x equal to, I'm going to make a quick calculation. Sorry, I don't have that one here up in advance. So give me 1 second to put that one in. 322.5. If I multiply that by 6, I get 1,935. And then if I divide both sides by 9 here, we can figure out what x is, and x is going to be the actual height of the building. Okay, so if I take 1935 and divide that by 9, I get 215 feet. So kind of cool. It's probably based on a real world problem. Like this is probably actually the case. We can use shadows and what we know about shadows and distances to do this in real life as well. As long as we have 3 pieces, we can find the 4th. And oftentimes we can measure the shadow of something on the ground pretty easy, but whereas if you were trying to measure the height of, like, say, prep, it'd be kind of difficult unless you had like a big ladder and you went up to the top of the roof and stuff like that. So this is kind of convenient for trying to figure out the height of things if you can't climb something really tall. So kind of cool math, kind of useful, and that's the final example. Excuse me. So for the homework, you know, I said 9 to 23 odds here, and it says 7.2, which is really weird. But I think what I want you to do is actually, so I'm not going to do that. Let's do 1 through 23 odds. We're going to skip number 15. There's your assignment, and we'll catch you next time. Thanks.